Hello VR students. At the request of Rohan, I actually recorded this video earlier, but today's been a super busy day, so I was trying to squeeze it in between meetings on my laptop. And I got like 3/4 of the way through the video and looked down and saw that it wasn't recording the audio. But by then it was time for me to roll into the next meeting. Yeah. So here I am, a little bit later than I anticipated, recording Rohan's request. Okay, so let me pull up the document that lists the specific methods I'm asking you guys to use, just so I don't leave one out when I'm explaining it. Okay, cool. Alright, so we're looking at using either walking in place. That one's pretty straightforward. Tapping in place, still pretty straightforward, but a little nuanced. World in miniature, virtual portals, rotational and translational gains, change blindness, and impossible spaces. Okay, so walking in place, that one explains itself. But just to be safe, you lift your feet up and down like you're walking, but you don't walk. You're just lifting them up and down. There's two ways to make that work. One is you track the feet, which you can do with the Quest. You have to get creative. Work with the tools you have. You can make it happen. So you can do foot tracking with the Quest, but not in a way that makes sense. Like I said, be creative. But you can also do walking in place without, and we talked about this in class too, you can do it without tracking the feet, because what happens when you lift your feet? Your head bobs up and down and sways left and right. And if you look at the senior project tips video for Unity that I also posted to the 447 Discord, I showed you how to write a script to track the position of a 3D thing, like your head or your hands or whatnot. And you can use that method to determine if a person's head is swaying back and forth or bobbing up and down or whatnot. So by looking at the position of the head moving, you can figure out if someone is walking. Now keep in mind, you can also request other methods. So like, we had someone do Spider-Man, like they would shoot out a web, and it would hit a building and they could swing, and that was really cool. We've had other students do swimming, which is like, okay, if you're going to do swimming, you really got to pull it off perfect, and they did. So using the controllers, they were swimming through the virtual world, and it worked. That was kind of cool. Tapping in place is like walking in place, but instead of lifting your feet up and down, you're moving your toes, you're tapping your toes up and down, or conversely, tapping your heels up and down. That is harder to detect by head tracking. So head bob is not as big for tapping in place. So you probably have to track, probably toes. Heels would be much harder to track with the Quest. And the fact that I said toes would be easier to track than heels, if you think about how the Quest tracks things like your controllers, that might give you a good tip as to how you can be creative to get foot tracking in the Quest. World in miniature. World in miniature is, well, you have a model of your world in miniature, like you're holding a map. And then you can, use your finger or your controller to select a place on that map, and then you jump to that position in the virtual world. So the camera position changes from where it currently is to go somewhere else in your virtual environment. That is a lot like teleportation, which you guys can't use for this. Yeah, you'd have some miniature representation, and that's Harriet Beecher Stowe apparently. Every time you lock the screen on this, it gives you a different author, or famous author, like Emily Dickinson. But anyway, pretend this is a map of your virtual world, or literally a miniature 3D model of your virtual world, and you select the spot that you want to teleport to, and then you teleport there. So that is world in miniature. This could also be, like I said, either a map or a little 3D model of your environment, either one. But it's going to have to match the world that you're in. And and let you select and teleport to those positions. Virtual portals, like the game Portal, if you play that. If you haven't, like Stargate or something like that, you use your controller and you point at a wall, and it opens up a doorway, or makes a doorway, and then you point at another wall, pull your trigger, opens up a doorway in that wall, and you can walk through this doorway and pop out of that doorway. And it's not just, making a block on the wall that when your head tracker touches it, you pop out from here to here. It needs to be something that you can look through. And I'm going to be honest with you, virtual portals is the hardest one you can possibly choose to implement. So have an idea of how you'd implement it before trying to do it. Okay? As a matter of fact, for all of these, try to think about how you would implement it before you choose it. Don't pick one because it sounds cool. Pick one because you think you can do it and it sounds cool. Rotational and translational gains, that's actually pretty straightforward. Remember, you control the physics of the virtual world. So if someone takes one step forward in the virtual world, or in the real world, you can have them actually move 2 steps forward in the virtual world, meaning they can travel twice as long in VR as they can in the real world. So that's a translational gain. Translational gains, pretty easy to implement, not terribly difficult. It's applying a multiplier to your position in the virtual world. Rotational gain is the same thing, but applied to rotation. So if I turn like 45 degrees in the real world, in the virtual world, the camera might actually rotate 50 or 60 degrees. So that would be applied, to this direction or this direction. So I would not recommend that you apply rotational gain to this axis, looking up and down, because that'll make people motion sick. So things to consider if you want to choose that one. Impossible spaces. Let's grab a thing to illustrate this with. We'll use this cell phone and Emily Dickinson. Okay, so a room. Pretend this is a room in the real world, and this is another room. In the real world, they can't overlap with each other, right? Because, well, things take up physical space. But in the virtual world, we can actually have the rooms partially overlap with each other. And when you're in this room, you don't see any of this room. And when you're in this room, you don't see any of this room. So usually how this is done is by having a hallway that connects the impossible spaces. So you exit one room, you walk out. Let me see if I can draw this on something. I think I can draw it here on my tablet. And it would, this will illustrate it a little better. Okay. Need to clear my canvas. Okay. Okay, actually, that's a terrible drawing. Okay. Okay, so here we go. Let's see if you can actually see this on the... No, it's too light. That's ridiculous. Look better like that? No, that looks worse. And I'm not editing this video, so you're going to see all of this happening. Okay. When all else fails, use good old paper, because paper is awesome. Or, in this case, I will use a piece of corrugated plastic board that I use as a door for my 3D printer, and a dry erase marker, because why not? Okay, So imagine having a room. Okay. So imagine this being a room, and you've got a hallway. So you exit the room, and you got a hallway that connects to another room. But this room partially overlaps with the other room. But you can't see any of this geometry when you're in here. See? When this little guy walks out of here, walks through the hallway, the room shifts. The hallway, not hallway, the wall will shift inward to this new position. So that when the little guy walks over here and is now standing in this room, you can see I'm kind of partially erasing that. This is the whole room that the person sees. So in other words, you change the environment when the person walks through the hallway. You shift this wall so that it's over here. So you're fitting more room, virtual room, into your physical space. That's called impossible spaces. Change blindness redirection. You change the world when the person's not looking at it. So if you do like we talked about in class, where you're moving doorways while a person's back is turned to them, or you could change the angle that a hallway is while a person's back is to it. In other words, you're changing what the virtual world is, the geometry of it, when the person's not looking at it. And then that way you can trick people into walking in circles or squares or whatever pattern you want. That one will also be challenging. So probably the two most difficult methods to implement are going to be virtual portals and change blindness redirection. Those are both really awesome ones, and I've had students do them with success, but those will be the most challenging ones. And like I said, you can use other methods as you think about them, but if you choose to do one that's not on the list, it's got to be a perfect experience. And on the note of experiences, I love you guys. You're great, you're awesome, you're fantastic students. I mean, but what can you expect? The students who take the VR class are some of the best students in our department, and they always have been, okay? You are now part of this legacy. So, having said that, your experience doesn't need to hit check boxes. So, you're not looking at a checklist, I've got this, got this, got this, I'm done. That's not what makes a virtual experience good. The checkboxes plus designing an experience makes it good. I know on the last assignment, a couple of you probably did it in like 5 minutes the night before, and you know, it was the first one. You got your critique in class, so you know it had its shortcomings in some ways. Don't just put virtual objects in a scene and say I'm done. You want to construct a visual experience. You're going to want to get on this early. You want to make something that people want to be in. And like I said, an important part of that is having a narrative that brings people into the experience. Start with a narrative. Treat this as not just a technical experience, but also a creative experience, an artistic experience. Because you're creating a world that me, the teacher, is going to be in, but also your your fellow students, your peers in the class are going to go into. And hopefully something that you can actually share as part of your development portfolio when you graduate and help you get a job. Because frankly, if you can make an excellent looking virtual world and demonstrate that to people who are wanting to hire a programmer, that's pretty darn impressive. So, you know, you're aiming for making a good experience. Don't forget that. Believe me, I won't when I'm grading it. So, you know, do that. If you got questions about making an experience, you know, let me know. I'm happy to chat with you about it. If there's an element that you're not sure you should include or you might want to change, again, happy to talk with you about it. I'm sure your classmates are also happy to talk about it too on Discord. I'm cool if you guys post prototypes, not your code. A lot of you for the games and experiences section, uploading your projects, have been posting your entire Unity project. Don't do that, because that means people can copy your code. You don't want them to do that. Only share your APK file on Discord. And if you got a work in progress that you want to share with your class, yeah, post the APK for the work in progress to that section on Discord, and have your classmates look at it and give you feedback, because I want you guys to create the best experiences you can, because ultimately I want to make awesome VR developers out of you, and one of the best ways for you to do that is to share your ideas and get lots and lots of feedback. The only way you can do that is get started on these things early and let people see what you got, including me. If you got questions, like I said, just let me know. I'm going to wrap this up now, and I will see you guys in class on Tuesday. Later, folks.